All right, this one says this is a statistics question, and it's supposed to be a chi-square test of independence for diet and exercise frequency. When I have rows and columns, I can do a chi-square test of independence. And the prompt, it's gives these different values. It says a researcher is interested in whether diet is related to frequency of exercise. A random sample of 300 adults was surveyed and the results are shown below. Healthy people exercise of 300 people. Those who are healthy, who exercise 3+ times a week, were 100 of them. Less than 3 times a week, 50. Unhealthy, more than 3 times a week, 60. Less than 3 times a week, 90. Prompt, at the alpha equals 0.5, test whether diet type is independent of exercise frequency. So H0. Diet is independent of exercise frequency. And H alternative, is they're not independent, or diet is dependent of exercise frequency. Okay, so I've got that. Is this a random sample? It certainly is. I've got rows and columns. By the way, the degrees of freedom is going to be the rows minus 1 times the columns minus 1. There are 2 of each. 2 minus 1 is 1. 2 minus 1 is 1. 1 times 1 is 1. The degree of freedom is 1. I'll need that if I'm going to calculate this by hand. Alpha is 0.05. So let me see. Let me do it the easy way first. Let me get my calculator here, and I will clear it, and I will go to stats. Not stats. I will go to second. I need the matrix. Hold on, it's not cooperating. Second matrix. And then I want it to be here. Let me clear these. Let me clear. I don't know what's in there. Hold on, it's not. What's going on? Let me enter. Okay. Oh, I see what I'm doing. Second matrix. I want to edit. And so 1, B is the one I want to clear. Oh, why won't it clear it? Hold on. Let me just reload this. I want to clear that matrix. I don't know why it won't clear it. Second matrix, I want to edit. Enter. A is a 2 by 2. I want B to be blank. So I've got my 2 by 2 matrix. Then I'm going to put the numbers in. 100 on the top, and then 50, and then 60, and then 90. And that's the matrix. Now I will go to stats, tests, and down to chi-squared independence, which is this one. Not the goodness of fit, independence. And observed is A, the matrix I entered. This is observed. This is observed. Expected is calculated. So it's going to calculate that and put it in B. And then it'll do the calculations. And it comes out with a chi-squared is 21.428. And it comes out with a P of 3.67 times 10 to the negative 6th. P equals 3.67 times 10 to the negative 6th. Well, that's going to go let me put it down here. 3.67, 10 to the negative 6. I need some zeros in front of that thing. And I go 1, 2, 3, 4, 5, 6. 5 zeros in front of 3. So 0.0000367, whatever comes after that. So that's a teeny tiny number. Let me compare it to my significance, 0.05. P is less than 0.05. I fail to reject the null hypothesis. I fail to reject that diet is independent of exercise frequency. There is not compelling evidence of the alternative hypothesis that diet is not independent of exercise frequency. There's not convincing evidence that diet depends on or is not independent of exercise frequency. Now you can calculate this whole thing by hand and you'll get the same numbers, but it's a long calculation. I guess I'll do it. You need the row totals, 150 for this one, 60 and 90 is 150, and you need the column totals. This is 160 and this is 140. And then for each category, and what are the categories? Healthy, 3+, healthy, less than 3, unhealthy diet, 3+, and unhealthy diet, less than 3. For each one of those, you have to calculate, and it's going to be the, the row total times the column total divided by the sample total, which is 300 in this case. I guess I should just write grand total. Okay, so let me do this for all of those. Let me move this down. I'm going to do it by hand just in case this is how it has to be done. I don't know. All right, by hand. So for 3+, healthy and 3+, the row total is 150, column total is 160. So this is 150 times 160 divided by 300. And what does that come out to? I'll check it on the old TI-80. 4. This is a long way of doing it. 150 times 160 divided by 300 is 80. And that's how you find the expected value, by the way. That's expected. The observed is the numbers that are actually in the table. So observed for healthy, that's what the experiment told me was 100. I'm going to need those to calculate the chi-squared value. Remember, chi-squared is going to be the summation of observed minus expected squared divided by expected. So I'll calculate for each one and then add them together. For H, healthy and less than 3, it is, the row total is 150, the column total is 140. So it's 150 times 140 divided by 300, whatever that equals. I don't need parentheses there, I'm going to need it here. 150 times 140 divided by 300. That comes out to 70. And the observed for less than 3 is, for healthy less than 3 is 50. Did I get that observed for the other one right? Yes. Now I have to go to unhealthy 3+. Unhealthy 3+, the column total is 160, row total is 150. So it's the same as the first one. 150 times 160 over 300 equals 80. Already done that one. But the observed number for unhealthy 3+ is 60. And then for why did that cut off? Hold on one second. I want to make sure I write this. Oh, because I moved it down. That's right, I moved it down. This is unhealthy less than 3. So for unhealthy less than 3, the row total is 150 times 140. So it's the same as the healthy less than 3. 150 times 140 over 300, which is equal to 70. And the expected value is 90, or the observed value rather is 90. Okay, so now I can calculate the chi-squared. This is 80 minus 100 squared divided by 80, which is 20 squared is 400 divided by 80. This one is going to be 50 minus 70 squared, divided by the expected, which is 70, which is 400 over 70. And then I'm going to add all these fractions together. And then this one is 80 minus 60 minus 80 is negative 20 squared, it's going to be, again, 400 over the expected 80. And this was going to be 90 minus 70, which is 20 squared is 400, divided by the expected 70, 400 over 70. So that's going to give me a chi-squared value. I've got 400 over 80 plus 400 over 70. This is the long way to do it. That other way is much easy. Plus 400 over 80 plus 400 over 70. 21.429, whatever, same value as the other one came up with, 21.429. So I can plug that into, this time I'm going to go to second vars, and I'm going to go to x chi-squared CDF, boom, and I think, well, I guess I don't already have it, 21.429. Upper bound, I need a very large number. I'll just put some very large number. Degree of freedom, for whatever reason, I've gone off the calculator. Degree of freedom is 2 minus 1 times 2 minus 1. 1 times 1 is 1. Paste, and put it in there. I get 3.67 times 10 to the negative 6th. 3.67 times 10 to the negative 6th, same value. And so again, the p-value is less than 0.05. I failed to reject the null hypothesis. There is not convincing evidence that diet is not independent of, or that diet is dependent of exercise frequency. So either way, the long way is a lot of calculation. The short way, very easy and fast. But they come to the same conclusion. Failed to reject the null hypothesis. There is not convincing evidence that diet is not independent of, or that diet is dependent of exercise frequency.